This lesson's on section 5.4, write equations in standard form. So we just recently did point-slope form, and we've been doing slope-intercept form for a while. So now we're going to talk about the standard form, the number 2 here in the middle. Again, I've got these kind of ranked in terms of priority, ones that we need to know. Not saying there's anything wrong with point-slope form, the one we worked with yesterday. And again, here's that form: y minus y sub 1 equals m times, in parentheses, x minus x sub 1. Nothing wrong with that form. It's just not one that we use a lot when we talk about linear equations. When it comes to graphing, solving, all those kind of things, we just don't see that one as much. So there's nothing wrong with that form. It's one to keep in the back of the mind. Again, it's the third most important one, I'd say, but still important enough that we're going to talk about it. And then we've been working with slope-intercept form, number 1 here a lot. Slope-intercept form is y equals mx plus b. And again, that's one that typically models a lot of different linear problems that we run into. One that we can make and graph very easily. So that's just the most popular form, the one we use the most often. Standard form is kind of the second most important one. And not necessarily because we're going to be able to change equations into this form to help us, but there are a lot of word problems that can model nicely in standard form. And so it's the other form that we can use kind of for word problems or for graphing using intercepts method, as we did in chapter 4. So this is the one we're working with here today, standard form. We've done slope-intercept. We just recently did point-slope form. Today we're going to talk about how can I make an equation into standard form, what does that look like, and what do I have to do. Below here I have just an example of equation that's in standard or in slope-intercept form. And again, while changing an equation from slope-intercept form to standard form may not seem like the most important thing in the world, just being able to realize that you can change back and forth, I guess that concept's important for students to know. Just realize that I can always get from one form to the other. There's a way to change it around and say, okay, well, if I need it in standard form for some reason, I can move this term here and divide it by this, and there it is. Or if I need to change it back to slope-intercept form, I can manipulate it around. So this is just good practice, at least if nothing else. Good practice for students to realize that they can manipulate the equation how they need to get it in the form they want. This problem right here, again, let's say this problem, this equation's in slope-intercept form, y equals mx plus b. And it says change this equation into standard form. Well, again, what does the standard form look like? That's up here, number 2. The big difference that I tell students to notice between standard form and slope-intercept form is that notice in slope-intercept form, the y term, that's all by itself on one side of the equation. In standard form, the y is still on the left side, but now the x is also over there with it. So the biggest thing to notice is that the x term and the y term are both on the same side. I know there's different variables here and constants or letters they have in the general form, a, b, c. Whereas in slope-intercept form, I know there's m and b, and those just stand for different types of numbers. It's not really important what they are or what letters they use there. The biggest thing to notice is our independent variable here and our dependent variable. And in this case, both x and y, those variables are on the same side. So whenever I want to change an equation from slope-intercept form to standard form, the only thing I got to do is get x and y on the same side. At least that's the simple way I describe it. So in this problem right here, if I want to change this equation into standard form, I kind of think about drawing my line just like when we were solving equations. And again, I'm going to manipulate it. I'm going to move things around. In this case, I want to get the x and y both on the left side over here. So what can I do? Well, I can subtract 5x from the right side. That'll get rid of it over there. Oops, not 15. And I can subtract 5x on the left side as well. When I subtract 5x on the right side, that gets rid of it from the right side. Now all the x terms are going to be on the left. And then I can write over here, negative 5x plus y equals 6. And there's the equation in standard form. So again, is that the most important thing in the world? No, but students should realize that they can manipulate equations back and forth and change from one form to the other as they need. So problems today, just like they were in the first couple sections, they'll give us a certain amount of information like a slope or a point or a y-intercept, things like that, things for us to work with. And instead the problems today will say, well, write the equations in standard form. Again, the one we're working with today. Well, how do we just directly make an equation into standard form? Well, there's not really a good way, unless it's a word problem. The word problem's, again, set up nicely with standard form, as we'll talk about in the next lesson. But in this lesson, just being able to manipulate an equation and turn it into standard form. How do we do it? Well, one way is we just cheat, actually, is what we do. So we actually just take an equation and make an equation in slope-intercept form, and then just change it into standard form at the end, which is pretty much what I have in red here. And if you're a student following along, taking notes, I want you to write that down. Today, when the problem says put an equation into standard form, we're going to put it in standard form at the very end of the problem. But really, how we do that is we just make one in slope-intercept form, like we've been doing in the first couple sections here of Chapter 5. And then at the end of the problem, we'll switch it around to standard form just like I did in that previous page. I get my answer where it's like y equals, let's say, 2x plus 3. And then I just subtract 2x from both sides and move the x term to the other side. That'll get it to standard form. So, looking down at like maybe an example problem here, it says write the equation in standard form. So again, directions look pretty similar as they have in this chapter, except for that part right there. Write the equation in standard form. Okay. Well, again, what I mentioned up here, we're actually going to cheat. I'm actually going to allow you to cheat in this part. And the cheat that we're going to do is we're going to make an equation in slope-intercept form instead, and then just change it at the end. So here's slope-intercept form as a reminder. Y equals mx plus b. When I'm telling students to make an equation in slope-intercept form, I always remind them to write down m equals and b equals, because again, it seems like a small thing, but often that can tell students, okay, what do I have to do next? They read through the problem, and do I have either the slope or the y-intercept? And if they don't, that kind of tells them, okay, maybe I have to try to find those kind of things and think about how they can do that in the problem. This problem says write the equation in standard form that passes through the line, or the line that passes through the points 2, 3, and 5, negative 9. So there's some line that passes through those 2 points, and I'm going to write an equation of it. Well, again, they didn't write in that information. They didn't give me the slope, and neither of these points is the y-intercept because neither of them has a 0 at the beginning. This is 2, 3, and that one's 5, negative 9. So neither of those points is the b. So in this case, I have to do some work here to find out what the slope and y-intercept are. Well, again, if we have 2 points on a line, one thing we're hopefully starting to get accustomed to is that we can find the slope of that line. I can do 3 minus negative 9 and 2 minus 5. 3 minus negative 9 and then 2 minus 5. And this can find me the slope of that line. 12 over negative 3, which just is negative 4. So, good, my slope is negative 4. Again, this should almost seem like a review for most students as I talk about in class. So far, I haven't touched anything new. This is the same stuff we've been doing for a while. Finding the slope with 2 points. Okay, we did that in Chapter 4, and then we use that in Chapter 5 here to make our equation. So this is nothing new. This section's almost a review up to this point. Now I'm going to find my y-intercept. And again, here's where my form of the equation can help me out. I'm going to put the slope, negative 4 here for m. And I'm going to take one of these points. Let's say it's the 2, 3. Okay, the 2 is the x-coordinate, so that goes in for x. The 3 is the y-coordinate, so that goes in for y. So now it looks like 3 equals negative 4 times 2 plus b. And there's my equation. So now, at least there's the equation that can help me get the y-intercept, to get b. Now I got to solve this and get b by itself. Negative 2 times 4 gives me negative 8. So 3 equals negative 8 plus b. Add 8 to both sides, and b equals 11. So I've got my y-intercept as 11. Just like we usually do, I can make my equation now in slope-intercept form. Y equals, oops, not m, we found that. Y equals negative 4x plus 11. But, again, all this would have been a review problem. That'd be nothing new. That's stuff we did in the first 2 sections. But now if you go back here and realize the only difference with this problem and the ones from the previous sections, it just says write it in standard form. So coming down here to my answer, how do I change this into standard form? Well, I just got to get x and y on the same side. So if this is negative 4x, I'm just going to add 4x to both sides. Now I've got 11 over here, and over here I've got 4x plus y. And there's my equation in standard form, and that's my answer. Again, all we've really done is, the section I should almost just call it a review of 5.1 and 5.2, but then we just add one step on at the end, just get the x term to the other side, and now we're in standard form. And again, this isn't really the greatest use of standard form, But it's a good thing that students should know. They should know how to manipulate an equation and move terms around. And they should be able to realize that I can change from standard form to slope-intercept form pretty handily. I'll do one more example of this, but again, it should seem kind of like a review problem. Write the equation in standard form that passes through the point 2, -3 and 4, -2. But again, when it says standard form, we'll just cross that off for just a little bit and think slope-intercept form. We're going to make one in that form because that's the one we know how to do pretty well. And then at the end, I'll kind of uncover this and say, okay, well now I'm going to do what it actually tells me. Make it in standard form. But first, we're going to start here. Slope-intercept form, because we know how to do that. So I'm going to make one equation in slope-intercept form. I'm going to find m and b. Again, in this problem, just like the first one, they don't give me the slope or the y-intercept. So I've got to find the slope by doing the subtraction. -3 minus -2 and 2 minus 4. -3 minus -2. 2 minus 4. If I set that up and then do my, let's see, it ends up being -3 plus 2 because it's a chop. So I get -1 on the top. And 2 minus 4 gives me -2 on the bottom. And -1 over -2 just gives me +1 over 2. The negative divided by negative gives me a positive answer. Something we've been talking about a bunch in class to make sure we understand that. A negative divided by negative gives me a positive. So it's just +1/2 for my slope. Now I'm going to take either of those points and set something up so I can find out what b is. Don't have that yet. So I got to find out my y-intercept. And again, neither of those points are the y-intercept. So let's say I'm going to take the second point this time. -2 equals 1/2 times 4 plus b. 1/2 times 4 is just 2. And then subtracting 2 from both sides, I get b equals -4. So now b is -4. I've got my slope, I've got my y-intercept. If I'm going to make this equation, it's y equals 1/2 x minus 4. And again, that'd be slope-intercept form, and that'd be the end of our problem in most of the other sections. But in this section, they're saying write the equation. Again, it says write the equation in standard form. So again, that problem was just a review of things we've done. Now I just got to change in the last step, though, and get x and y by itself. And this one, I just have to subtract 1/2 x from both sides. And again, usually you put the x term first. You don't have to, though, but I've been doing that. So it'd be -1/2 x plus y equals -4. And there that equation is in standard form. One more thing this section talks about that can come about when we're talking about equations that are in standard form is it talks about equivalent equations. And again, this is something else I'd have you write in your notes. Equivalent equations. Those are equations that have the same set of solutions. So all the answers that are like some ordered pair that would fit for one equation, they would also fit for the other equation. And if all the ordered pairs work for one equation that work for another, remember ordered pairs are just like points on a grid. So if I'm saying that all the points for this equation are the same as all the points for this equation, if I graph them also, they should have the exact same graph. So let's try that with these two equations. I'll tell you right now they are equivalent. But let's try graphing this red one and this blue one and see what I get for the graphs. This equation right here says 3x plus 4y equals 12. If I use intercepts method, and again remember this was standard form was the nice method to use when the equation was in standard form, then we should use intercepts method to graph. It's the easiest one. That's where I put in 0 for x and then divide 12 divided by 4, and that gives me 3 for the y-intercept. And then I come back here and say, okay, now I'm going to put in 0 for y. 12 divided by 3 gives me 4 for the x-intercept. So my intercepts are 0, 3, and 4, 0. And so here's what that graph might look like, something to that effect. Now I'll graph the blue one. Do the exact same thing. Put in 0 for x, 0 for y. If I put in 0 for x, it just gets rid of that term, so I cross it off. 24 divided by 8 gives me 3. Come back to the original equation. Put in 0 for y. 24 divided by 6 gives me 4. So the intercepts for this one are 0, 3, 4, 0. What do you know? Okay, that is the exact same equation. If I graph them, they're right on top of each other. So that then asks the question, okay, how do I make equivalent equations, or how can I tell when that I have equivalent equations? Well, if you look at these two, you may be able to notice a connection here. Notice this one's 3x plus 4y equals 12. This one's 6x plus 8y equals 24. Well, what do you notice between all the numbers from this equation, the red one, to the blue one, is that what happens is they just are all multiplied by 2. Okay? If I take 3 times 2, I get 6. 4 times 2, I get 8. 12 times 2, I get 24. In equivalent equations, there's some common factor like this that relates the two. So if I want to make more equivalent equations, I can make even some other ones. Okay, I'm going to take this red equation down here. Just say I want to make another equation that's equivalent to the 3x plus 4y equals 12. Well, all I have to do is, let's say I'm going to put a big parentheses around it to say that I'm going to multiply it all by something. Okay, I could just multiply it all by 3 instead. So if I just multiply every single number by 3, well, what do I get? Well, I get 9x plus 12y equals 36. Okay, and this equation right here, I'm saying, is also equivalent to the red and the blue one. If I try to graph this, okay, I'd have intercepts. If my y-intercept would be 0, 3 again. 36 divided by 12 would give me 3. 36 divided by 9 would give me 4. So there'd be my x-intercept. And yeah, what do you know? It's the exact same graph still. I kind of missed it there, but it's the exact same graph. It falls right on top of the red and the blue one. If I want to make more equivalent equations, again, I could just take this red equation and just multiply by some other number. So let's bring it over here. Let's say I'm going to multiply everything by 10. Okay, it doesn't matter what number I would pick. I could even pick negative 10. It wouldn't matter. If I multiply everything by negative 10, I'd get negative 30x minus 40y equals negative 120. Okay, and if you still try to graph this one using intercepts method, put in 0 for x, put in 0 for y. You can check it out yourself. But I'll tell you that the y-intercept will be 3, the x-intercept will be 4. And what do you know? It'll be 0, 3, 4, 0. And I'll have another equivalent equation. They all fall on top of each other. So some of the problems today say make an equivalent equation of the one they give you. All we have to do is just take that equation and multiply it by some factor, and we can create some equivalent equation for that one. So just an example of what I was talking about on that previous page. If I want to write two equations that are equivalent to, well, let's say this one here, x minus 4y equals 10. What I could do is just start by saying, okay, x minus 4y equals 10. Let's take everything and multiply everything by 2. Well, if I do that, my new equation here I get is 2x minus 8y equals 20. And again, you would see that if I graph both these equations, they'd have the exact same graph. If I want to take that same equation, oops, it's not going to drag with me this time, but I could take that equation, and it says to make 2 of them, so I got to make another one here. I could take that same equation and multiply it by, let's say, 7. If I do that, I'll get 7x minus 28y equals 70. These two equations would be equivalent to that original equation. If we graphed all three of these equations, this one, and this one, we'd find, like we did on the previous page, they'd all fall on the exact same line. So that's creating equivalent equations with standard form equations.